Alright, so in this video I wanted to discuss why it's important to know the internal loads within a structure. Alright, so the reason we need to know what internal loads are within a member or in a structure is because if you know what the internal load is within a structure, you can predict whether or not something will fail. Alright, so in your MME 312 course, which is like strength of materials and mechanics of materials, you're going to use statics to determine what are the internal forces within a member. And then you're going to use material properties to determine whether or not a specimen with a specific geometry would fail or would be able to withstand a given applied load. So, for example, if we have specimens, all right, and these are tensile bars, all right, in tension, all right, we did a section cut at an internal surface. What we'd notice is that we'd have an internal force that would be in tension. Alright, this is our normal force. Alright, and it would likely cause a fracture at a given load. So if n exceeds the limit, alright, we would have failure would occur. Alright. So and then for a so in the same case where we had a instead of having a tensile load, we had a compressive load, like drawn on the left-hand side here. Right, and we took a section cut of that surface. What we'd end up getting is you would get a compressive internal stress within our sections. All right. All right. Now, compressive internal forces, especially in longer members like those that are used in buildings, can lead to a phenomenon called buckling. And buckling typically occurs a lot in structures with long columns that are unsupported. And the reason buckling is important is buckling typically occurs at relatively small, I should say, internal loads. So something typically will fail much earlier in buckling than it would fail in the same internal load under tension. Right, so then the third type of failure mechanism that's often found is if you have shear. So a common example where shear forces can cause internal failure is in bolts. So if you have a bolt that's under a shear loading condition, that's drawn on the left-hand side, it can cause the bolts to fail, like this, and you get like massive plastic deformation of the bolts. So this is caused by internal forces at that point here, and if those exceed the limit, you're going to see failure of that bolt. Alright, and then the last two failure mechanisms are due to bending or torsion. So we're going to go to the next page. So if you have a beam here, and this is a concrete beam, alright, and it has an external load being applied to the structure. What ends up happening is it develops a very large moment at the internal surface here. All right, and when that internal moment exceeds the limit of the material and of the cross section, what you end up getting is you start to develop cracks in the system, and those cracks will propagate until eventually you get a fracture of the material. All right, and then the last type of situation is if you had a torsion or a torque. So these are two examples of torsional failures in mechanical components, and typically this is found a lot in drive shafts within engines and transmissions. So typically what happens is if you took a section cut of these systems, what you end up getting is you get a moment that would go along the axis of the member. All right, so you'd say, so if m of y is greater than the limit for the part, you would have failure would occur. All right, so in MME 312, which is the Mechanics of Materials course, and in MME 411, which is Machine and Tool Design, all right, you will be you are going to what you're going to do in those courses is you're going to relate the loads and the material properties of these parts to predict failure in engineering components. Alright, so that concludes this video on the motivation behind why internal forces are important to understand in order to predict failure within engineering components.